Hello and welcome. My name is Rajesh Mehta, and I'm a part of the leadership team here at Smarten. Smarten, which is powered by Elegant JBI, one of the oldest business intelligence platform built in India, which has been used by customers across the country with companies like Sharekhan, Religare, RPG, NTDB. It's listed in multiple Gartner reports, and this particular presentation is going to take you through on a small journey introducing you to assisted predictive modeling, which is a part of the augmented analytics suite that we are offering to the users. Assisted predictive modeling allows users who have no background in R or in scripting or in statistics to run complicated analytics or complicated predictive or statistical analysis on their business data to take effective decisions. So this is what it is going to be about. So I'll start off on this presentation, and there will be a video which will be either a part of this video or a separate video which will be on our website, where I will actually demonstrate using dummy data as to how effectively and simple it is to do analytics on Smarten, predictive analytics on Smarten. So this particular demonstration is focused on consumer goods and similar type of products. So the model we are going to be using would have, say, wholesaler, stockist, sales representative, staff which is on the floor of the store, or basically reaching out to end users, doing below the line activity to generate demand, and there is an expense for that, and then there are sales representatives. So that's the kind of scenario we are going to look at in this particular demonstration. So generally speaking, what we have in terms of a business is that we have data which is shown as the orange block at the bottom, and you can put assisted modeling on top of it and get insight, predictions, and suggestions out of it. And it's in cycle where the data generate. You have history of the data, and then you generate insight, and you get suggestion, and you augment the data, and this cycle kind of continues. Now, usually what's the requirement? The requirement is that there is, there are data sets or data silos or databases which are in different systems or are in different formats or in, say, or different files, which need to be merged together to make sense and run the predictive analytics on. So say, and good example would be that your transaction data would be in your ERP, which would be like SAP or Navision, and or maybe some other ERP, and the rest of the stuff might be in a CRM, and there would be some data which would be in the interactive system which you have with your wholesalers and CNFs. So all this data needs to be brought in together, and you can make a kind of an analytics which would allow you to predict which component in which area. Like, say, for example, the CRM would give you product complaints, which would give you an indication of product quality and how it impacts the sales. So and you can get a weightage for that. So this is how we expect the predictive analytics to work, and this is possible in Smarten. There are two key components in Smarten which make this possible. One is the self-service data preparation, which allows you to bring in data from multiple sources, put them together, cleanse them, get it ready for analytics, and then push it simply into the assisted predictive modeling, which will select the algorithm and give you the right analysis. So without writing a single line of code. So what happens is that in a more complex environment, you may have to build different data sets for different businesses, and then you kind of bring the output from each of these data sets into a final data set on which you can run the analytics. So say, for example, manpower. You would have information about the manpower. You would like to connect it with the sales data, and you want to see as to which of the individual traits of your manpowers have an impact on the sales. So what you will get is that, say, from the manpower or the HR module, you will get factors that most impact the sales, the factors in HR that least impact the sales, and what is the volume or the quantum of sales which get impacted by each of these factors. So here's how a model would look like. Say, say we have to look at a position, and then based on that there are different parameters which come from the either the transaction system or the HR system, and you run a regression analysis on it as well as in classification, and it gives the factors which have a positive impact, factors which have a least impact, and you can get a classification based on characteristic work patterns and effectiveness to find more valued employees in the organization. So say for example, a factor with positive impact would be overall experience, and a factor with least impact would be education years. I mean, hypothetically speaking. Now once you have the output from this particular module, you can take the output and put it into you can use this effectively. I mean, that's one way. I mean, you can use it for performance enhancement, and you can kind of fine tune your recruitment policies. Meanwhile, what you can do is that you can take the 6-7 parameters which matter the most here and put it into another repository, and which can be used along with the key items from each of the modules here, like from the distribution, from the dealer performance, from the BTL, ATL, product innovation, price fluctuation, and say each of these small data sets would possibly have a few values which impact positively and few values which impact negatively, and all these parameters are put together and you can see the overall impact on sales. So generally speaking, you will have transaction patterns, payment, location, you will have sales by distribution, you will have visits, sales, collections, and you will have linked marketing data for promotion, advertising, and schemes. And you're going to use this data to kind of create an predictive analytics model. Now, if you look at the key advantage that we have here is that because of self-serve data preparation, building the core data is very easy for your technology or the IT department, and for the users to kind of create new modules and work on them, it's as easy. So it works both ways. So here are a few examples of the possibilities. So say for example, here we have taken macroeconomic data. We have taken data from the core transaction, and we have taken the retail end user data. So say industry data and the transaction data and the macroeconomic data, you can put up finding out what would be the possible growth in the business. So say when you're planning your business and you want to see whether the targets you have taken would be in alignment with the organic growth in the industry, and if the actions you are going to take will give you the incremental growth which is necessary. So say for example, if you are in the business of selling paints, you would rather look at the cement industry, link it up to the cement industry and kind of correlate it and see how the cement industry has been performing compared to your business, and draw a relationship and make a forecast for organic growth. A similar thing, you can look at the effectiveness of the sales promotion, and like the example which I explained earlier. And also you can do very ad hoc analysis, like say for example, what is the impact of wholesale price index or holidays on end user participation in BTL activity. So there is a good chance that as the prices of consumer products goes up, the participation in the promotion activity increases, because people are not willing to spend money and rather do and look at a promotion activity. You can also do an analysis of how an advertising campaign or any of the other macroeconomic factors have impacted your business. So this is how it looks like. I mean, it is you can take a decision which is at a micro level, which is like a regional sales manager taking a predictive modeling, to a decision which would be taken by the CEO. You can make plans based on the predictive model, and short-term as well as long-term plans, and then you can connect this to macroeconomic data to kind of validate it also if required. So that's the three blocks which make up the whole thing. So now this is how the interface looks. The forecasting, classification, clustering, correlation, regression, frequent pattern mining, and hypothesis testing. These are the built-in algorithms which are there in our system. And assisted predictive modeling automatically detects the moment you select this and push the data onto it, it will select the right algorithm and kind of give you results based on that. So you will have three possible ways of getting around it. One is that you will have a reusable standard predictive model for, say, looking at how the market is going to be in the coming month or so. You will have another model for taking a decision, which would be like, say, I have got about 100,000 to spend on my customers. Which customers should I spend these on? That would be an assisted model for day-to-day decision taking. Or then it would have a model for strategic decision taking, which maybe you could run it a year or once a year or twice a year. It includes everybody. It includes the technology team who builds the data. It includes the business analysts and the technology team, where basically they can put in the models together. And assisted predictive modeling works with the end users. The data can be built by the end users. So here's a example of a predictive for sales scheme. You get your transaction data, you have a past scheme data. Scheme would be an kind of a promotion or a proposal to your customer, which basically has an incentive to buy more. The parameters for there, the expense for advertisement. You run a regression analysis and you can get a sense of the sales which is expected, focus which is required for different regions, and the parameters which will have an highest impact, and what would be the cost of the ETL, BTL. So this is the kind of model which can be generated and run regularly. And this is then we can have a model for planning. Okay, so basically, you can have the credit note, discounts, macroeconomic data, combine it, run a regression, and you can do a trend and a forecast. You can get the focus areas, you can get the macro data which it will connect to, and the performing parameters. You can also do hypothesis tests, whether it is the people which are effective or, say, the sales scheme which are more effective, what matters the most. So what new product and effective launch parameters. So if you're launching a new product, which are the parameters which have the most effectiveness in getting the salesperson as well as the retail end of the spectrum to be active, and what type of spend or what type of people should be activated to kind of focus on getting things done. So same thing for targeting on specific areas. So this kind of brings us to the end of the presentation, and what we will do now is that we will kind of have a look at the demo of the product, and I will show you a couple of very good examples of how you can put this to use in your life. Thank you.